Hey everybody, I'm Meteorologist Nick Stewart, and I want to take a quick look at the catastrophic flooding situation that unfolded in Texas on the July 4th holiday, and just exactly what it looked like meteorologically, the timeline of events in terms of the different weather service products, and exactly what meteorologically led up to this event. Now, there's going to be some really deep research in the weeks and months and years ahead on to exactly what happened here. So this will be very kind of a top level approach to the meteorology as to how things unfolded. Certainly, a lot of factors did stand out. So we'll take a look at those, the forecast, and again, the timeline as things unfolded. So first and foremost, the Weather Prediction Center. This is their official forecast for what we call excessive rainfall, basically the potential for flash flooding. And 2 days in advance, we did have that level 2 risk, a slight risk that did encompass the areas that will be impacted by the flooding. And of course, the day 1 risk, the day of risk, continued to have that slight risk in place. We were likely going to be looking at the potential for slow-moving thunderstorms capable of very heavy rainfall rates due to a very, very moist environment. So a lot of moisture for this system to work with. On a top-level view, in terms of these excessive outlooks, the forecast was there in terms of flash flooding, but of course this really doesn't capture the really high end potential. Most fatalities will happen in a level 4 risk, a high risk for excessive rainfall. That's where the vast majority of your fatalities will occur in terms of flash flooding. This was only a level 2 risk. Now, 15 hours and 17 minutes before the very first report. So we're going to be basing this on the official reports into the National Weather Service. So for 15 hours in advance, we did have a flood watch, which was issued by the National Weather Service in Austin, San Antonio. And a few things to point out here. One, it did include some of the counties most heavily impacted. We did also, of course, have that mention of heavy rainfall that could cause flash flooding. They did mention isolated amounts of 5 to 7 inches possible. Now, this event produced upwards of 10 inches or more of precipitation, so it was a little bit under the max ceiling that we actually did see, but this is still a pretty high impact event either way. Even without those 10 inches of rainfall, 7 inches would still be enough to cause some pretty significant issues. They did talk about excessive runoff leading to flooding at rivers, creeks, streams, and low-lying flood-prone locations. The areas most heavily impacted certainly were flood-prone areas. And they do also mention that you should monitor forecasts for potential flood warnings, and that living in these prone areas, definitely be prepared to take action. And here's kind of what it looked like early on. They did again mention, of course, 5 to 7 inches of rain will be possible, and there is your area most heavily impacted by the flooding right up here. So about 9.5 hours before the event really unfolded, we had one of our first mesoscale discussions. So these are issued by the Weather Prediction Center, and they talk about all of the factors that will be in place for the potential of heavy rainfall. Most people that will see these are going to be emergency managers, broadcast meteorologists, and of course government employees. Local National Weather Service employees will see this as well. And they do make several mentions inside of this discussion, including an MCV, a mesoscale convective vortex, also a trough in the mid part of the atmosphere that's leading to very strong low-level jet, about 5,000 feet above your head. So strong winds at the low-level jet, transporting a lot of moisture into this portion of Texas. So this is really setting up for a potential flash flooding threat. They do mention that rainfall rates of 3 inches plus per hour will be possible, and that backbuilding will be a concern over the hill country. That's the areas most heavily impacted by this event. They also do note that locally considerable flash flooding this evening is possible. We did have an extension of that flash flood watch. We're about 8.5 hours now before things really take a turn and we start seeing those widespread flash flooding reports. So the flash flood watch is in effect until 7 a.m. on Friday. That encompasses the worst of this event. They still mention the 5 to 7 inches of rain will be possible. They do mention that excessive runoff will result in flooding of rivers, and you should continue to follow those latest forecasts. Most apps will show it on a home screen. If you have a weather app, if you know rain is in the forecast, you will see generally something of a flood watch in effect. Also, do note that a flash flood watch was replaced by just a flood watch to simplify things. And so you're not going to see a flash flood watch anymore. They've been replaced by just a general flood watch for what it's worth. Here's that extension, and you can see those flood watches extend way off to the northwest now, including a huge part of the area, and still mentioned 5 to 7 inches of rainfall will be a possibility with that. So we have another mesoscale forecast. So this again will be going out to local media. This will be going out to the local weather service offices, local emergency managers, first responders, anybody that's in the chat rooms of weather products. They're going to be getting this information. Note, this is now after midnight on July 4th, so a lot of people are likely asleep at this point in time. But what they do note here is that some flash flood impacts could be significant. That's a really big thing to note in this discussion now. And again, we're about 4 hours ahead of the first reports of major flash flooding. And they also do mention that rainfall totals of 6 inches in a 6-hour period will be possible. These areas of heavy rainfall are expected to result in flash flooding, some of which may become locally significant. Here's a rainfall radar loop. And again, here's that star, kind of the area most impacted. You can see how this thunderstorm sits there, and you start getting some training. So that's when you get multiple thunderstorms forming and hitting the same places over and over and over again. And that's really what you see. And also of note, you can see that flash flood warning pop in right there, that green polygon there. So it does come in relatively early ahead of the rainfall. It's only raining at this point in time for maybe an hour before we start seeing these flash flood warnings coming out, and they start coming in quick. Here is that first flash flood warning for the areas most heavily impacted by it. This comes in at 1:14 a.m. on July 4th. So again, most people will be asleep at this point in time. This was a considerable threat. So most alerts, this type of alert will go to your WEA. So everybody that has them enabled will get this type of alert, a wireless emergency alert. Assuming you have not turned those off, you will get that to your phone. Cell phone service does exist in this area. In fact, there are posts on social media talking about people that have gotten these alerts, and they were kind of aware of the potential flash flooding threat. Looking at that flash flood warning, again, we're more than 3 hours before the first reports start trickling into the Weather Service. They do mention, of course, the areas impacted. They mention that flash flooding is ongoing or expected to begin shortly. Life-threatening flash flooding, highlighted there. They do mention, of course, the areas most heavily impacted, some of the campgrounds here in the wildlife management area, also another state natural area. So they do mention some of the areas that people will be camping at. This flash flood warning did get multiple updates through time. You would see these updates on local media. You would see these updates on apps, weather apps and things, but you probably aren't getting these directly to your phone, just to know. At 1:45 a.m., they note that 2 to 4 inches have fallen, with 2 to 4 inch rainfall rates per hour continuing. At 3:19 a.m., they mentioned that 3 to 7 inches of rain has fallen, with an additional 2 to 4 inches possible. So here's where you're really starting to see them get the high-end totals more accurate in their wording messaging. And then by 3:35 a.m., they mentioned that 4 to 8 inches of rain has fallen, with an additional 2 to 4 inches of rain will be possible. So they really start upping that potential here. And here's when things really escalate. So this is at 4:03 a.m., July 4th. This is your flash flood emergency. Once again, this will trigger wireless emergency alerts. So these will go to your phone, assuming you have them turned on. They are on by default. Generally, I'm pretty sure they're on by default for everybody. You have to actually go in and turn them off. Most people turn them off because they get annoyed. Crying wolf. That's likely going to be a big contributing factor to fatalities with this event as research goes on. So anyway, here's your flash flood warning. The flash flood emergency. This is 32 minutes, again, prior to the first reports coming in of flash flooding ongoing. They mentioned flash flood emergency. Of course, that area is impacted. Numerous low water crossings, as well as the Guadalupe River, are flooding. They mentioned that 4 to 10 inches of rain has fallen. They do mention that more rainfall is to come in the next hour, and they do mention additional rainfall rates are coming. This is a flash flood emergency. Particularly dangerous situation. Seek higher ground now. They are really upping the verbiage here in this flash flood warning. But again, this is 4:03 a.m. If you have the alerts turned off, they're probably not waking you up. You're probably not getting this information if you're sound asleep, right? Move to higher ground. Extremely dangerous, life-threatening situation. It is important to know where you are relative to streams, rivers, or creeks, which can become killers in heavy rain. I do think that in time, this is something that might get added to some higher end flood watches in the future. I think this is something that could be highlighted. When I was back in the TV world, one thing that I would always talk about in terms of the flash flooding threat is if you're camping. As we go through the day on Sunday, if you have camping plans this weekend, make sure you know where the waterways are and how to get to higher ground. The rate that these creeks, streams, and even rivers can rise in torrential rainfall, it's quick. And you'll see that here. It's very quick. And so you really need to watch these things. And I think highlighting this potential of where you are relative to streams, rivers, or creeks, that might be another thing that might come out of this, where campgrounds along rivers might get better messaging, or at least some, signage of if you are in this area, be mindful of flash flooding, right? They might have already put this in this river. In fact, I do believe downstream of the areas most heavily impacted actually do have sirens for flash flooding, but I don't believe, unfortunately, the areas that were most heavily impacted did not have those warning sirens in place. But again, a lot more information on that will come in the days and weeks ahead. Just to show you how rapidly things evolved here, here's one of the stream gauges for the Guadalupe River at Hunt. At 2 a.m., the river was normal at about 8 feet. At 3 a.m., it started going up to about 10 feet. 3:30, it's now 15.9 feet. It's almost gone up 6 feet in a half an hour. Then at 4 a.m., it's at 21.1 feet. By 4:35, it's at 29.45 feet, and that is the last reading we got before the stream gauge was likely topped. So we don't know exactly how high the river get. This will likely be done in a post-event analysis to exactly how high the river ended up going. The record there is 36.6 feet. But again, what's so remarkable is how fast this river rose. You were at 8 feet at 2 a.m., and then by 4:30, so 2.5 hours later, it was at 30 feet. It's hard to fathom, truly, just how quickly this water rose. And this report at 29.45 feet, this is also when the very first report came in, the first official local storm report into the National Weather Service, where the county sheriff's office was reporting several low water crossings flooded in South Central County. So that's when your first reports were coming in at 4:30 in the morning. We had some other reports down the road. Again, there's your first official report at 5:44 a.m. Here's when emergency management was reporting high water rescues were ongoing along the South Fork of the Guadalupe River, people on rooftops. Here's kind of just everything condensed. The flash flood watch was issued at 1:18 p.m. on July 3rd. We did have, just after midnight, some flash flood impacts could be significant. The first flash flood warning for this particular area was issued at 1:14 a.m. At 4:03 a.m., that was upgraded to a flash flood emergency. And then, about a half hour later, we had the first reports coming in of flooding into the National Weather Service. So just how quickly this event accelerated. Sort of well forecast in the short term, in terms of probably about 12 hours out, we knew flash flooding was becoming likely. And about 6 hours out, I think, is when we really started seeing the high impacts becoming more likely. But I wouldn't say it was super well forecast longer term. Like, this wasn't a thing that we saw, a day or two in advance. It just ramped up incredibly quickly in a short period of time. Here are those flash flood warnings. Again, the same polygon, but just had multiple updates in that same area for this particular flash flood warning. Looking at some of the observed totals here with this event, this is from Coco Ross, And these are likely not the absolute peak rainfall intensities. They will likely find some higher totals with some, digging. There might be some other reports that haven't yet come in yet, but you can see there is an 8.98 inch report there. And you also have other reports over 8 inches kind of in this area, 7 inches right here. So a lot of heavy rainfall reports in this particular area. Looking at the official analyzed data, this takes in official reports, some radar analysis as well, and you're talking over 10 inches of rain fell just upstream of Kerrville, and that's where we had some of the most significant loss of life, which is truly, truly heartbreaking in that area. Really see a localized area of really high-end totals that led to so many issues, and a lot of other flooding concerns well upstream as well of that. I want to talk about kind of what led up to this now. And one of the biggest driving factors of this system was Tropical Storm Barry. Made landfall there in Texas off the Gulf Coast. Made landfall late June. So that'll be around June 29th, June 30th. And this pumped an enormous amount of moisture into the atmosphere. You can see it on the water vapor satellite imagery here. You get this moisture rides, it kind of starts moving northward, but it's just kind of crawling and just sitting here across the state of Texas. Again, and that's what led to the heavy rainfall that you see unfolding there. Here again, here's your loop. You got a lot of moisture coming on in, and it just kind of sits here. There's no real push in the jet stream to kick this moisture out of here. And that's what kind of led to the flash flooding threat, is you had this enormous amount of moisture sitting in place. Looking at some of the analogs, so this is based on what has happened historically, and we look at events that are similar in terms of upper level pattern, moisture patterns, and we look at what may happen based on that. We try to compare, several days to what looked very similar. And when you look at the median, so this is kind of like the dead center of the analogs, there's virtually no rainfall here across Texas. But the 90th percentile, so the high-end concern of the analogs, did in fact highlight this potential for significant rainfall in South Texas. So I like to look at analogs, and these are products that I look at when in terms of flooding potential. I used to forecast for the upper Midwest. We would get a lot of flash flooding concerns. A lot of the rivers would rapidly rise. And these two products I would look at when there was a concern for flash flooding. So you kind of have a middle ground forecast, which is virtually nothing. But then you have this 90th percentile. So kind of an outlier. But if you know that you're going to get storms, this median doesn't make sense. What makes sense maybe are those higher end potentials. And so that's one thing when looking through some of the data after the fact, this really stood out to me. This 90th percentile really honing in on some potential. That top analog was June 22nd, 1999. And I had to look up NOAA's storm data. And what I found was rather interesting. For Kerr County, you had, in fact, they mentioned up to 5 inches reported in Hunt, and as much as 7 inches in Fredericksburg nearby. And so you had widespread flash flooding, closed roads, inundated low water crossings. And when you look at the rainfall amounts here, kind of a bit of a reanalysis, you can see 3 to 4 to 5 plus inches of rain nearby on the top analog. It's not the exact same areas, but this analog at least kind of hinted that, hey, maybe we have to watch something here. And when you look at the precipitable water values, that's a measurement of just how much moisture is in the atmosphere, we're pushing more than 2.25 inches here across South Texas. And the rainfall reports on the top analog here, just another way of looking at it, are over 3 to 4 inches here in this kind of bullseye. This is kind of a lower resolution than this product. But again, it just kind of shows that potential for significant heavy rainfall. And that analog did kind of hint at it on, again, the 90th percentile, so the high-end potential. Looking at a rainfall radar loop of that event back in 1999, you can see a lot of heavy rain falling here across the same areas that were kind of impacted. So this is a radar loop from the 1999 event, and here's a rainfall loop from the last little bit there from the event that just happened in 2025. So this slow-moving thunderstorm, kind of similar, right? Kind of over the same areas. When looking at the overall weather pattern for how things unfolded in the 2025 event, you have this kind of weak ridging here across the southern central plains. Fairly weak ridging here, not a real strong trough in the jet stream, so it's not really kicking that moisture out. And you're also dealing with rather high end moisture. So your moisture levels at 700 millibars, so middle parts of the atmosphere, loaded. Your relative humidity at 80-90% or so, and then at 850 millibar, so about 5,000 feet above your head, you're still looking at 80 to 90% relative humidity. And again, the precipitable water value, very high end here, over 2 inches across much of Texas. So an immense amount of moisture. There are certainly red flags that potential concerns were there for flash flooding. What really helped get this event going was, of course, the moisture in place, but also at about 700 to 500 millibars, so middle part of the atmosphere, we had a bit of a negatively tilted trough. It's fairly subtle, but it's enough to cause showers and thunderstorms to develop just with forcing with ascent, right? So that's how we're getting all this activity here, this negatively tilted trough kind of pivoting through portions of central Texas. That was enough to initiate the storms, and of course we had the moisture in play. Here are your PWATs, your precipitable water values. This basically is a measurement of just how much moisture is in the atmosphere. If you condense it all to rain, that's how much would fall instantaneously. And you have some very high end totals here, 2 to 2.4 inches. That's very, very high end moisture levels for the atmosphere. So looking at an observed sounding, and again, I cannot stress enough how important these weather balloon launches are. There's been a lot of talk about budget cuts and DOGE. Nothing really directly impacted this event from an outsider view, in my opinion, because nothing was cut in this area. The weather balloons were still flying. The weather models are all still running. And as far as I know, these weather offices are not particularly hard hit as much as others. So everything was still functioning, in my opinion, based on some of the reports we're getting as well, that some of the National Weather Service offices were bringing in extra staff to make sure they're staffed up. So this weather balloon near the Del Rio region, there are, again, a lot of red flags here. One, of course, the measured precipitable water value of 2.34 inches. That is very high end. And that middle part of the atmosphere, that mid-level relative humidity over 80%. So a lot of moisture, not only in the whole column of the atmosphere, but also in that area where you're going to start seeing clouds develop and thunderstorms develop to tap into a lot of moisture. Of note too, the freezing level is very, very high here. That freezing level is over 16,000 feet. So very elevated freezing level. That means all this moisture here is falling as rain. There's no graupel, there's no hail forming. It's all rain. This environment too, as you can see, the red line temperature, the green line dew point, it's very saturated. So the entire environment is very saturated. And we also had weak veering. You got winds veering with height. That's enough to kind of keep sustained updrafts, sustained thunderstorms. And that's evident here. This sounding, this weather balloon, which is so critical again to our forecasting, there's alarm bells everywhere here. And that's why, again, the National Weather Service was really pushing these high-end flash flood warnings. They put out the flash flood watches in advance. A lot of things were flagged here as being a major concern. Looking at historical reference, that 2.34 inch measured precipitable water value with records dating back to 1954, for July 4th, that is the fourth highest measured value. So that just goes to show just how high end this was. And if you take out the fact that all three of these are pretty much the same exact event, this is the second highest, measured value for a day, calendar day. The mean here is 1.45 inches. We're at 2.34. So very high end. And that's why we're looking at near record to record levels of moisture in the atmosphere. So if you know thunderstorms are going to develop, if you know thunderstorms are going to be slow moving, and you know there's this amount of moisture in place, again, screaming alarm bells for flash flooding threat. Looking at how the weather models themselves performed, the individual models, They're helpful, but when you can take a bunch of different models, you average them all together, and you look at kind of the high-end threat, this product is one of my favorites for looking at flash flooding.
But again, this could be much, much higher. In fact, some models that we look at are indicating the potential for 7 inches of rainfall in southern Minnesota to northern Iowa.
When it comes to flash flooding, the probability matched mean product does a really good job of capturing, in my opinion, the reasonably worst case scenario for flash flooding. And what you can see here, it was a little south of the main area we're watching here, but it did indicate very nearby the probabilities of 5 to 7 inches of rainfall in that area. Also kind of bimodal with another heavier threat up to the north as well, which actually kind of did happen if you remember that analyzed precipitation. But again, you can see some very high-end rainfall totals here nearby. So again, the models were also hinting at it as well. The individual models were kind of all over the place. So for example, the high-resolution rapid refresh kind of showed this really high-end potential here. The NAM Nest kind of missed out on the southern target, was more fired up on the northern target. And then the ARW, which I really like as a forecasting tool, did also show that really high-end rainfall threat, but again, a little further south. So the models are a bit further displaced, but when you average them out together with that probability matched mean product, it did really show that potential for extreme rainfall was certainly a possibility. And this came pretty darn close, and this was that night. So 0Z on July 4th. So they were basically getting these products in real time. If you look back about 12 hours, the last time this product was run, kind of a similar story in terms of showing some heavier rainfall threat. Not quite as loud as this signal, but it was there. Just not quite as loud. But again, it did show that potential for flash flooding. That was kind of a bit of a long-winded video, but I have been asked for it on my Facebook page. People were wondering, what the heck happened here? And I hope this provided a little bit of an overall kind of top-level view of just exactly how things unfolded. Not only the warning process and the timeline of how things unfolded, but also the meteorology that went into it. Again, what led to this extreme rainfall, tropical moisture from Tropical Storm Barry making landfall, pushing northward. That was a huge driver. Very weak upper level support, so not really kicking that moisture out and letting it kind of pool there. That was a big driving factor as well. You had that mid-level troughing, that little negatively tilted trough around 500 to 700 millibar. That was enough to cause forcing with descent. And that led to shower and thunderstorm develop in a very, very rich environment with a lot of moisture that was near, if not record breaking. So the alarm bells were there. The forecast did catch up. And in terms of getting the warnings out, we had watches and warnings well in advance of the flash flooding actually taking place. Was it super well forecast? No. But it's very difficult to forecast these, 1 in a 100-year type of events. We don't have the modeling, and that's why it's so important to continue research in flash flooding, to continue developing our weather models as well, to make them better and better, to one day really be able to forecast these things even better. We've come a long way, and we're going to continue to get better, assuming we continue to invest in getting better and better at forecasting. So I hope this answered some of your questions and your lingering thoughts about how things unfolded here. If you do have any more questions, feel free to let me know in the comments down below. You can reach out to me on Twitter, Facebook, etc. Those are all be linked down below as well. Thanks for watching, everybody. We'll see you again next time.